I was recently reading about a bug with random numbers in JavaScript. It's a distribution bug that's a result of the way that JavaScript picks a random number between 0 and 0.99, often said as 0 and 1. Anyway, I was curious if I had this bug in some of my code, but before I went and checked some of my code to see if it did have this bug, I also wanted to do a quick test, so I thought I would do that today. Alright, so the first thing I want to do is just open my editor. And I'm just going to reuse the one I have open already. And I'm going to create a new file for this test, and I'll just call it rand.dst.jas. This is JavaScript, and I'll run it through Node in this case. So I might as well open a new terminal window down here while I'm at it. And so the first thing I want to do is set up some values, some counts basically of how many times it's picked a certain number, and then set up min and max variables. Then I want to loop a bunch of times, and I don't know how many I'll do exactly, but maybe I'll start with 1,000 or so and then go from there. Inside my loop, I'm gonna pick a random number, and then I'm going to add that to a variable, and then I'm going to output the results. And what I'm looking for is basically the distribution of these picks. So let's start with a variable, and I'm just going to create an array with 6 values in it, because I'm going to set a minimum of 1 and a maximum of 6. So like a die pick, basically. We'll be picking a number between 1 and 6, and then in this picks array, I'm going to store the number of times we picked each of these values. So pick 1, 2, 3, 4, 5, 6. Of course, this array is 0 based, so I'll have to subtract 1. All right, so let's loop a bunch of times. So we'll write a loop. Iterator is 1, and while it's less than, say, 1,000, we will add 1. So that's the loop. And then inside the loop, we need to pick a random number, and we need to add that to our variable. So picked number is Math.floor, Math.random times max plus the minimum. This is kind of the standard random number method you'll find if you look on Stack Overflow or something like that. And so that should give us a random number between 1 being the minimum and the random number of 6. And we're going to round that down using Math.floor. And that's the most common advice I see. And then we're going to set our picks array to whatever that value was. And because it's a 0-based array, like I said before, we're going to subtract 1 from the picked value, and it will just increment that value. So basically, if we picked a 1, we'll subtract 1, so element array 0 will be incremented by 1. And we'll do that 1,000 times. I can pull all these to-dos out now because most of this is done. And then we need to output the results. And I'll just output that whole array. So I think that's good. And then I'll just run node rnd.dst.js, and there's our distribution. So we can see that we picked 1,000 times. We picked around 150, 160, 170, 160, 180, 160, 150. That looks pretty good to me. Let's increase that to 100,000 picks, and we'll just run that one more time. And look at that, 16,000 of each, 16.5, 16.4, 16.6, 16.8, 16.8, 16.5. A couple of these look a little high, but that's probably just a result of randomness, and I think that's a successful pick of random numbers, and I think the distribution is safe. We could even add another 0 to this if we wanted. Not sure how long this will take. Oh, not much time at all. Oh, let's add one more 0. And oops, I didn't save that last one. So you can see it's right in this ballpark. So that one looks good. Distribution of that looks good. So we used Math.floor, and maybe my own intuition would be to use Math.round initially. You have to change your math in here just a little bit. You've got to do you've got to do max minus 1, I think, because you're picking a random. You might round up or you might round down in this case. And with me having said that, you might already know why this is a bad idea. But let's run this again. Actually, I haven't saved it, so I'll save it. And then we'll run rnd.dst.js. All right, now we see variation. So we're getting around 200,000, or I guess that's 1.9 million. In these ones, 2 million, 2 million, 1.99 million. But then on these ones, we're only getting 100,000. Or sorry, not 100,000, close to 1 million. So 1 million here and 2 million effectively here. So you can see in this case, because we're rounding up or down, the first number and the last number get half the distribution that the rest of the numbers get. And that's just true for the first number and for the last number. So that's pretty interesting. Well, that would be an easy mistake to make. There's one other thought I had doing this. I don't know if anyone would do it or not, but if Math.round doesn't work, maybe we could just go with Math.ceil, and we could always round up instead of rounding down. And then we need to change our math yet again. Actually, the code for this is simpler, because you can do you can just do math.random times max. In this case, my min is 1. So I can just use max. Then I'm not using this min variable, but we'll ignore that for just a moment. Anyway, it simplifies this code a little bit, right? That's a tiny bit simpler math function. So let's make sure I've saved that, and then I'm going to clear this as to not confuse it with the end, and then we'll just run the distribution again. And actually, I was expecting this to be wrong, but it turned out right. Oh, that's right. So this one looks right. this one looks right. And if you're just doing this test like I am here, you might come to the conclusion that this is a pretty good random number. It's equally distributed. However, there is a very, very, very small chance that you could choose a 0 in this case instead of a 1. And so because of that, this one's wrong too. So the best one to use is Math.floor, and then Math.random times max, and then add your min, as I did in the first case. This is the correct one that gives you an equal distribution with no option of a 0 being picked. So there you have it. Now I need to go check my code to see if I have ever used anything other than Math.floor in my JavaScript code to pick a random number and see if I got unequal distribution. I did notice one more problem with this code too after I recorded this little demonstration. My for loop sets the iterator to 1, and then the comparison is I is less than 1,000. That should have been I is less than or equal to 1,000, so that it picks a number between 1 and 1,000, whereas the code as it is picks a number between 1 and 999. Not a huge deal, but similar to that ceil thing that I was just talking about, where it's off just slightly. Also, I mentioned ceil picks a number between, sometimes picks a 0 or sometimes picks a 1. What I actually meant was it sometimes picks a 0 and sometimes picks like 0.01 up through like 0.99. And when it does pick a 0, your dice roll in that example is 0 instead of 1, and you were trying to pick a number between 1 and 6, and so 0 is not a good choice. Doesn't happen very often, but can happen. So anyway, hope you enjoyed this little demonstration of random number distribution in JavaScript. See you soon.